Somewhere out past the edge of our solar system, more than 12 billion miles from where you are sitting right now, something reportedly moved through the darkness. And within hours, the claim was everywhere. Not a planet, not a star. According to a wave of posts that spread across social media in the space of a single week, Voyager 2, the 49-year-old spacecraft humanity launched back in 1977, had picked up on something moving with what one widely shared post described as spooky fluidity, something that did not match any known natural pattern. Some versions of the story went even further, suggesting the signal could be a fragment of alien technology drifting through interstellar space, silently observed by a probe never designed to look for anything like it. The claim spread fast precisely because it landed on a spacecraft people already feel something for, an aging machine humanity sent out decades ago that is still, against every reasonable expectation, sending data home from a place nothing else has ever reached. So is there anything real underneath this? Here is what actually happened and why the true story turns out to be almost as strange as the rumor, just for completely different reasons, rooted in real, verifiable science rather than an unsourced quote sitting inside a blog post. Stick with me for the next few minutes because untangling this means separating two very different things: a genuinely fascinating documented discovery buried in Voyager's real data, and a viral claim that falls apart almost immediately once you go looking for where it actually came from. Let's start with the spacecraft itself, because you cannot fairly judge this claim without understanding exactly what Voyager 2 is capable of detecting out there in the first place. Voyager 2 launched on August 20th, 1977, technically before its twin Voyager 1, even though Voyager 1 would go on to overtake it and cross into interstellar space first. Voyager 2 became the second human-made object in history to cross that threshold, doing so on November 5th, 2018, 6 years after Voyager 1 made the same crossing back in August of 2012. Today, Voyager 2 sits more than 12 billion miles from Earth, some sources putting the figure closer to 19 billion kilometers and climbing, traveling through a region of space that no other operating spacecraft has ever directly sampled. It carries a small handful of still-functioning instruments, including a magnetometer that measures magnetic fields, a plasma science instrument that measures charged particles directly, and a plasma wave subsystem that detects oscillations in the electrically charged material drifting through the space between stars. These instruments were never built to take pictures or visually spot objects moving nearby, because Voyager's cameras were deliberately shut down decades ago to conserve its rapidly shrinking power supply. Whatever Voyager 2 detects out there, it detects through subtle shifts in magnetic fields and plasma density, never through anything resembling a photograph or a visual sighting of any kind. It helps to understand exactly how limited Voyager's remaining toolkit really is at this stage of the mission, because that limitation is the single biggest problem with the viral claim. Each Voyager spacecraft launched in 1977 carrying 10 original scientific instruments, and only a handful of those still function today after nearly 5 decades in the harshest environment humans have ever sent hardware into. NASA's mission engineers have had to make increasingly difficult choices about which instruments to keep powered as the spacecraft's plutonium-238 power source keeps losing roughly 4 watts of usable electricity every single year. A slow, irreversible decline with no possibility of refueling or repair. The imaging cameras that once captured now iconic views of Jupiter, Saturn, Uranus, and Neptune during Voyager's grand tour of the outer planets were deliberately powered down once that tour ended, since there was nothing left to photograph in the empty darkness beyond the solar system. And every watt saved meant more years of scientific data from the instruments that actually remained useful out there. This is precisely why any claim describing Voyager watching something visually move through the darkness should immediately sound suspicious to anyone who understands the spacecraft's real, well-documented, publicly available instrument configuration. That detail alone should raise your eyebrows the moment you encounter the viral version of this story, because several posts circulating online describe Voyager catching something gliding through space with, in one widely shared post's own words, spooky fluidity. Language that strongly implies some kind of visual observation actually took place. Voyager 2 has no working camera. It physically cannot see anything glide, drift, or move in any visual sense whatsoever, full stop. Any claim describing Voyager watching something move through space in a visual way is describing an ability the spacecraft simply does not have and has not had for decades, no matter how convincingly a headline frames it. It also helps to understand just how much history is already riding on this particular spacecraft before any viral rumor ever touched it, because that history is part of why the story spread so easily. Voyager 2 launched from Cape Canaveral on August 20th, 1977, 16 days before its twin Voyager 1, taking advantage of a rare planetary alignment that occurs only once every 175 years, allowing a single spacecraft to use the gravity of each outer planet to slingshot toward the next one. Over the following 12 years, Voyager 2 became the only spacecraft in history to fly past all 4 of the solar system's giant planets: Jupiter in 1979, Saturn in 1981, Uranus in 1986, and Neptune in 1989, a feat no mission before or since has managed to replicate. Each spacecraft also carries a golden record, a phonograph disc loaded with sounds, images, and greetings in 55 languages meant to represent life and culture on Earth, in case either probe is ever recovered by another civilization millions of years from now. That detail alone has fed decades of public fascination and occasionally decades of misunderstanding, since some viral posts conflate the golden record's intentional message to any future finder, with the idea that Voyager might now be actively detecting a response of some kind. It is not. The record was a one-way message sealed before launch. Nothing about Voyager's current instrument suite is capable of detecting, translating, or responding to anything resembling contact, deliberate or otherwise. So where did this rumor actually come from? And is there any real data hiding underneath it? Tracing the claim back, it appears to originate from a blog post rather than any NASA press release, peer-reviewed paper, or Jet Propulsion Laboratory statement of any kind. That post describes a mysterious wave or ripple passing through space, first floated as a possible shockwave from a distant supernova or an unusually powerful stellar flare, before claiming the signal did not match any known or previously cataloged pattern. From there, the post speculates that Voyager might have detected a rogue plasma structure, or, in its own words, possibly a fragment of extraterrestrial technology. It even attributes a dramatic quote to Suzanne Dodd, Voyager's real, actual project manager at NASA's Jet Propulsion Laboratory, suggesting that the ordinary rules of physics might work differently out there. Here's the problem. That quote does not appear anywhere in any verifiable NASA statement, press release, or interview transcript connected to this specific claim. Dodd is a genuine scientist who has given plenty of real interviews about the Voyager program over the years, discussing everything from the spacecraft's dwindling power budget to the team's difficult decisions about which instruments to keep alive. But attributing an unsourced, dramatic quote to a real named scientist without any traceable original source is exactly the kind of move that should make anyone pause before sharing a story like this any further. This particular version of the story has also been repackaged across dozens of different video titles and channels, each one using nearly identical phrasing, nearly identical framing, and, tellingly, the exact same unsourced quote word for word. That repetition is itself a warning sign worth understanding. Genuinely independent, well-sourced scientific discoveries almost always get reported with at least some variation in wording, because different outlets do their own reporting and interview their own sources rather than simply copying one another. When you instead find dozens of separate channels reproducing the identical, unverifiable phrase, what you are actually looking at is one blog post's language being copy-pasted across the internet at scale, not independent confirmation of anything. While we're separating verified science from unsourced internet rumor, it's worth knowing that this exact pattern shows up again and again with Voyager specifically, precisely because the mission sits at such a perfect intersection of ingredients for viral content. There's a genuinely mysterious, real discovery buried somewhere in the data. Almost every time NASA publishes new Voyager findings, there's an almost unimaginable distance from Earth that makes independent verification difficult for casual readers scrolling past a headline. And there's a spacecraft, old enough and famous enough that most people already carry a kind of emotional attachment to its story without even realizing it. When a modest, real scientific finding, like an unexpected plasma density gradient, gets filtered through a blog post that is optimizing for engagement rather than accuracy, it becomes remarkably easy to dress up a genuinely interesting but fairly technical data point using dramatic language about gliding movement and hints of alien technology, especially when the original scientific paper behind the claim is dense enough that almost nobody reading the viral version will ever actually go check it. This is also not the first time a real Voyager finding has been quietly rewritten into something more sensational after the fact. Back in 2017, NASA released audio derived from Voyager 1's plasma wave data, an actual sonification of real electromagnetic oscillations converted into sound so the public could get a sense of what the instrument was recording. Almost immediately, edited and slowed down versions of that same audio began circulating online labeled as an alien signal or a mysterious space transmission, when in reality it was simply a scientific data set translated into something audible for outreach purposes, exactly the same underlying pattern showing up again here with the plasma density story. The lesson from both cases is the same. If a headline about Voyager describes something visual, auditory, or communicative that goes beyond what a magnetometer or a plasma wave instrument can actually record, it is worth pausing before sharing it, because the spacecraft's real capabilities are a matter of public record and have not meaningfully changed in years. A simple habit worth building the next time a viral space claim like this shows up in your feed is to ask 3 quick questions before sharing it further. First, does the claim describe something the instrument involved is actually capable of detecting, or does it describe an entirely different capability, like vision or sound, being retroactively assigned to a machine that never had it? Second, is there a named, dated, peer-reviewed paper or an official space agency statement behind the claim, or does the trail dead end at a single blog post with no further sourcing? And third, does the exact same quote or phrase show up word for word across dozens of unrelated channels, which usually signals one uncredited source being copied at scale rather than independent reporting, confirming the same story from multiple directions? Here is what Voyager 2 has actually verifiably detected out in interstellar space, and it does not require a single fragment of alien technology to be remarkable in its own right. Both Voyager 1 and Voyager 2 have used their plasma wave instruments to measure real, documented oscillations in the density of interstellar plasma, the thin, electrically charged soup that fills the space between stars. When Voyager 1 first measured plasma oscillations after crossing the heliopause on October 23, 2013, at a distance of about 122.6 astronomical units, it detected a plasma density of roughly 0.055 electrons per cubic centimeter. Voyager 2 crossed that same boundary, called the heliopause, on November 5, 2018, at a distance of about 119.7 astronomical units, more than 11 billion miles from the Sun. Then, in June of 2019, Voyager 2's instruments picked up a sharper jump in that density, to about 0.12 electrons per cubic centimeter, at a distance of roughly 124.2 astronomical units. Researchers publishing in the journal Nature Astronomy confirmed this was not a fluke unique to one spacecraft, that the increase in plasma density appears to be a genuine, large-scale feature of the very local interstellar medium, the region of space immediately surrounding our solar system. This was a genuinely unexpected finding when it was first published, since scientists had generally predicted the solar wind would simply fade away gradually the farther a spacecraft traveled from the Sun, rather than encountering anything like a distinct boundary at all. Don Gurnett, the University of Iowa physicist who served as principal investigator on the plasma wave instruments for both spacecraft, put it plainly when the findings were announced, saying, "The old idea that the solar wind gradually gets whittled away the further you travel into interstellar space simply is not true, and that Voyager had shown there is a genuinely distinct boundary out there in space." The way scientists actually detect these plasma oscillations is itself worth understanding, because it explains why the real discovery can sound almost as strange as the fabricated version once you describe the mechanism plainly. Voyager's plasma wave instrument does not directly sense the density of surrounding particles, the way a thermometer senses temperature. Instead, it listens for natural oscillations, essentially a kind of electrical ringing that occurs when the plasma surrounding the spacecraft gets disturbed, often triggered by something as simple as a burst of solar activity from our own Sun rippling outward and reaching Voyager years after it first erupted from the Sun's surface. By measuring the specific frequency of that ringing, researchers can calculate the density of the surrounding plasma with remarkable precision, essentially using the physics of the universe itself as a built-in measuring instrument millions of miles from the nearest laboratory. When multiple readings, gathered years apart as the spacecraft kept drifting outward, consistently showed rising density figures instead of leveling off or declining the way older models predicted, that persistent trend is exactly what caught researchers' attention and turned a routine data feed into a genuinely notable scientific finding worth 5 separate published papers. On top of the plasma density measurements, Voyager's magnetometer readings have also picked up real ongoing fluctuations in the magnetic field structure of interstellar space, patterns that help researchers understand how our Sun's magnetic influence blends into and interacts with the surrounding galactic magnetic field far beyond the heliosphere's edge. Interstellar space, it turns out, is not the smooth, empty void many people picture when they imagine the region between stars. It is turbulent, uneven, and filled with plasma waves, magnetic ripples, and shifting particle densities that Voyager's instruments happen to be uniquely positioned to measure, simply because nothing else humanity has ever built has traveled far enough to sample this region directly. In other words, the actual verified science already contains something genuinely strange and worth talking about. Interstellar space turning out to be far more dynamic and structured than older models predicted, all without needing to invent an unsourced quote about alien fragments to make any of it interesting. There is also a simple incentive structure worth acknowledging honestly here. A headline describing a subtle, gradual rise in interstellar plasma density, however genuinely significant that finding is to researchers studying the structure of our galactic neighborhood, is never going to generate the same instant curiosity as a headline suggesting a spacecraft might have detected alien technology drifting past in the dark. Content built around that second, more sensational framing tends to spread faster, get shared more widely, and keep viewers watching longer, which creates a constant temptation to nudge real, modest findings toward more dramatic-sounding territory. one exaggerated word choice at a time, until the original accurate finding is barely recognizable underneath all the added theatrics. This pattern is not unique to Voyager either. Genuine scientific findings involving distant spacecraft, unexplained astronomical signals, or edge-of-knowledge physics get run through this same transformation constantly, across dozens of missions and dozens of unrelated discoveries every single year. A real, modest technical discovery gets rewritten with invented quotes, dramatic framing, and a vague implication of extraterrestrial involvement, because that version reliably generates far more clicks than an accurate description of a plasma density measurement ever could on its own. Recognizing this pattern is honestly one of the more useful skills anyone can develop as a consumer of space and science content online, because it lets you separate the genuinely exciting real discoveries, and there are plenty of them, from the manufactured excitement built entirely on top of a real discovery's name recognition. None of this is meant to take anything away from how genuinely remarkable Voyager 2's real achievements actually are, because, if anything, the true story is more impressive than the fake one. This is a spacecraft built using 1970s technology, running on a radioisotope power source that loses a small amount of usable electricity every single year, with absolutely no way to replenish it. It is currently drifting through a region of space so remote that its own radio signals, traveling at the literal speed of light, take somewhere around 18 to 19 hours just to reach Earth, compared to roughly 8 minutes for light traveling from the Sun. And despite every one of those constraints, it is still actively contributing new, previously unknown information about the structure of the space surrounding our entire solar system. Information that, quite literally, could not be gathered any other way, since no other instrument humanity has ever built has traveled far enough to measure it directly. Consider what it actually takes to keep this data flowing at all, decades after launch. The engineers working on the Voyager mission today are often decades younger than the spacecraft itself, which means many of them had to learn programming conventions, command structures, and documentation styles from an era before they were even born. Simply to keep interpreting the readings, these aging instruments continue sending home across billions of miles of empty space. Every single plasma wave measurement discussed in published research represents years of patient monitoring, careful calibration, and painstaking analysis by a team working with a machine that offers no possibility of in-person repair or upgrade under any circumstance, ever, for the rest of its operational life. The Voyager team has had to shut down instrument after instrument over the years purely to conserve power, prioritizing which experiments stay alive based on which ones are still returning genuinely useful science. A triage process that will likely continue until the spacecraft can no longer power even a single working instrument, sometime in the early 2030s. According to current mission projections. That context alone makes the real discoveries buried in Voyager's data considerably more impressive than any invented claim about alien fragments could ever hope to be, because nothing about it required exaggeration to begin with. It's also worth putting Voyager 2's current distance in perspective, because the numbers involved are genuinely difficult for a human brain to hold on to. Voyager 1, the faster and more distant of the two probes, is now more than 15 billion miles from the Sun and still climbing. Voyager 2, having taken a longer route past Uranus and Neptune during its planetary tour, trails behind at somewhere around 12 to 13 billion miles out, still moving away from us at roughly 35,000 miles per hour, fast enough to cross the entire continental United States in about 4 minutes. At that speed, and after nearly 5 decades in flight, Voyager 2 is still years away from encountering the outer edge of the Oort cloud, the vast shell of icy debris that marks the true gravitational edge of our solar system, a boundary the spacecraft is not expected to reach for another roughly 17,000 years, if its power hasn't run out entirely long before then. Every fact in that description is public, published, and easy to verify through NASA's own mission tracking pages. None of it needed an unsourced quote about alien fragments to be worth a headline. It's also worth understanding why NASA continues funding a mission this old in the first place, since the answer says something about why the real science here matters more than the manufactured version ever could. Every dollar spent keeping the Voyager team running buys something that literally cannot be purchased any other way right now. A direct, real-time sample of a region of space no telescope on Earth or in orbit can observe from the inside. Ground-based and orbital telescopes can infer things about the interstellar medium by studying starlight passing through it from enormous distances, but they cannot measure the local plasma density, temperature, or magnetic turbulence the way an instrument physically sitting inside that environment can. That is precisely why the Voyager interstellar mission, the formal name for this extended phase of the program, remains a priority for NASA's heliophysics division, even decades past. The point anyone expected the spacecraft to still be operational, and why the 5 papers published in Nature Astronomy in 2019 were treated as a genuinely significant moment in space science rather than a routine data update. Losing Voyager's remaining instruments to power decay will mean losing humanity's only direct sensor in interstellar space for years, possibly decades, until a future mission is designed, funded, built, and given enough time to travel anywhere near that far out again, which is part of why mission engineers have been so deliberate and conservative about which instruments they choose to power down each time a difficult decision has to be made. So here is the honest, complete picture once you actually trace the story all the way back to its source. Voyager 2 did not catch anything gliding through space in any visual sense because it has no functioning camera capable of doing so, and it hasn't for decades. There is no verified NASA statement describing a mysterious moving object detected by either spacecraft. That dramatic quote attributed to Voyager's real project manager does not appear to come from any traceable, verifiable interview, press release, or transcript anywhere in NASA's public record. What Voyager 2 has actually done, quietly and without any need for embellishment, is help reveal that interstellar space is more turbulent, more structured, and more scientifically active than older models assumed, through real, published measurements of plasma density and magnetic field behavior gathered by an almost 50-year-old spacecraft that nobody involved in its original 1977 launch expected to still be working this long after leaving Earth. If a future measurement genuinely does turn up something unexplained buried in that data, it will arrive the same way this real discovery did, through a peer-reviewed paper named Researchers, Specific Published Numbers, and a journal willing to put its own credibility behind the claim, not through an unsourced quote sitting inside a blog post with no citation trail anybody can actually follow back to a real source. That real story does not need alien fragments or spooky fluidity to be worth your attention, because a machine built before most of the internet's current population was even born is still, right now, expanding human knowledge of the galaxy, one carefully measured plasma wave at a time, from a place so remote that everything it teaches us has quite literally never been learned any other way in the entire history of our species. That is not a rumor. That is simply what Voyager 2 has been doing this entire time, patiently, honestly, and without any need for embellishment, a genuinely remarkable achievement that somehow still keeps getting overshadowed by a version of events nobody can actually trace back to a real source. If you appreciate a channel willing to trace a viral claim all the way back to its actual source instead of simply repeating whatever version sounds the most exciting, that habit of checking before sharing is worth carrying into every space story you come across from here on out, not just this one. There's a lot more genuine Voyager science still worth covering in the years this aging spacecraft has left. Real findings that never needed an invented quote or a fabricated sighting to earn your attention in the first place. And separating those real discoveries from the noise around them is exactly the kind of work worth doing every single time a headline like this one shows up again.